Okay, so today we're looking at, we remember the other day we were looking at the mean and the standard deviations, and you can only use that for symmetric data. So this is the same with standardized or Z-score. So what a Z-score is, it is a number, it tells you the number of standard deviations you are away, from the mean. So the number of standard deviations away from the mean. So what that means, if we remember back to our bell shape, sorry, mine's a little bit bad here. So if you have the bell shape, the Z-score at the mean is actually 0 because you're no distance, no standard deviation away from the mean. If you're up here at 1 standard deviation above the mean, your Z-score will be 1. If you are at -1 standard deviations away from the mean, your Z-score will be at -1. So you could have a Z-score of, say, -0.5 and you'd be in between there, okay? So that's what we'll roughly be doing to interpret people's results and stuff using their Z-scores. So the way you calculate the Z-score is you actually take the data value. So you might want to write here the actual value. It sort of is a little bit clearer if you know it's that, because then you'll see in the worded questions when they actually give you what they got, you'll know that's the actual. And obviously the mean is the one X with the line above it and standard deviation. So just down here on that formula where we've just used the symbols, maybe just write SX because that's what it is on your calculator. Okay, so as we just saw then, you can have positive or negative Z-scores because if you are below the mean, if you have a negative, you will be below the mean. And if you have a positive, you'll be above the mean. So, sorry, these ones just don't have the line above it. Okay, so that's just summarizing that. So we're going to be using these Z-scores. So let's do some examples. So sometimes you have to find the actual data value. So when we say that, that's like finding the X. Okay, so if you have to find the actual data value and you've been given the other things, so you've been given the mean and you've been given a Z-score, so they've told you what they got and the standard deviation, you can use this formula. It's just a rearrangement of that one before, but might just make your life easier if it's, you've got a formula like that. So I don't remember, if you remember last time back to remember we were doing the crickets questions with the 68, 95 and 99% rule. So they actually had told us in the previous questions that I believe that the mean was 12.7. So the mean was 12.7 and the standard deviation was 2.3. So they told us that in this question. So now we can continue on. A cricket nymph has a length of 11.2. So what they just told me there was the actual. Yeah, so they said he has an actual of 11.2. So they're asking me to calculate the Z-score, the standardized length. So you can write standardized score or you could call it Z-score, it doesn't matter. And it's saying to 2 decimal places. So write your formula for Z-score. So it is that, and then we'll just pop in the data. So the actual was 11.2 minus 12.7 divided by 2.3. And what do we get? That you might have done it wrong. All right, so I get negative 0.65. So if I was to interpret this or comment, what does this tell us? So this is a Z. So just to help you out, so if you were asked to interpret, maybe even explain it, okay? This is how we're going to do that. You're going to think about where it fell in your bell shape. So if you've got the bell shape there and the mean would be here, this is where our negative 0.65 would fall. So it's not quite past the 1, but it's past the mean. So what I would say for this one, that this one is, it means you're in the bottom 50%. Yeah? So their score was in the bottom 50%. If it was over here, like in just past the -1, but not in the 2, I'd say it's in the bottom 16%. Because remember those pockets? Remember when we had 1, we said that little pocket was 16%. Okay, so that's how you interpret. Let's do some more practice. So here's some more practicing of calculating the Z scores and then sort of interpreting or telling why we do this. So you could have this person who does all these different tests and their class averages means would be different. But we're going to standardize their scores so that we can see really where do they rank, where's their best subject in terms of everyone else. So if we have a look here, so if we were calculating the Z score for this first one, remember this is X, this is our mean, and this is our standard deviation. So this one would be 69 minus 60 divided by 4. And we get, so we get 2.25. If I do the biology one, I'll get 75 minus 60 over 5, which equals 3. So this is the Z scores that we're calculating. This one, what would the Z score, if you got 55 and the mean's 55, I don't even need to work it out. If you're on the mean, you've got a Z score of 0. This, in further, it was 55 minus 44 divided by 10. So what does that end up being? 1.1. And then the last one, we've got 73 minus 82 over 4. So we're going to get a -1 here. Okay, this one ends up being -2.25. So where you're going to rank, so if we were drawing the bell shapes here, just so you know, this one would be 1, 2, if you had 3. This one here, the 2.25, is up there. If you draw the bell shape here, 1, 2, 3, this guy here is at the 3. This one here, obviously he's on the mean, so this score was on average. And then this one, if you draw this, you got the mean, you have 1, 2, he's falling into there. And this last one would be negative. So just to show you, it'd be down here, oops, -3, -2, -1. This one will be in here. So it's in there, so I would say in the bottom 2.5% for that one. So that's what we're going to say. We can make a comment about them. So here, because in this first one, because it's a bit higher than 2, but it's just gone past, I'm going to say comment and say it's in the, because when you have 2 standard deviation, that little tail is 2.5%. So I'm going to say in the top 2.5%. In this one, it's even further higher. This looks like the best performing because he's in the top 0.15%. I know that because that's the little tail for 3 standard deviations. This one, I'm going to put a positive spin and say he's in the top 50%. He's in the bottom 50% too, but either way. And this one, because it's at 1, this little tail means he's in the top 16%. And this one, they're down is in, because it's past the 2, we're going to say the bottom 2.5%. Because that 2 would be, -2 would be, have a 2.5 tail. So if I go to rank these, obviously the best one was bio, then followed by, what was it, English, then further, then chem, and then finally psych was his last one, or their last one. Okay, so a student's standard mark on a class test is negative 2.1. On the basis of this score and assuming the test marks are normally distributed, it can be concluded that. So if I think about where does this fall on our bell shape, -1, -2, -3. So it's somewhere in here. So if you go 2 and below, you're in the bottom 2.5%. And if you go from the 3 down, you're in the bottom 0.15%. So if you look at the answers there, it says in the bottom 2.5, which is what we said, of marks in the class, but not in the bottom. This one's the best answer. The other ones are just a little bit, we don't even use 5% ever. So like in terms of that, so in the bottom 5%, you'd be looking for the numbers like 2.5, 0.15 or 16%, but this A is the best answer. So let's just move on. So to question 2. So a student's standardized mark on the test was this, negative 1.7, and the mean for the class was 55, and the standard deviation was 2.85. It says their mark on the test is closest to. So you want to use that formula before where we had actual equals, and remember, so it equals the mean plus the Z score times the standard deviation. So if you plug in that data here, we'd have the mean is 55 plus negative 1.7 times 2.85, and the closest it is probably 50. Okay? All right, so let's do this one. The weights of male players in a basketball competition are approximately normally distributed. So as soon as you see that word, you know you can use the mean and the standard deviation, and they've given us that. The mean is 78.6 and the standard deviation is 9.3. They just said there are 456 males in the competition, so they just told me the total. And they're asking the expected number, so this is a number of males in the competition with weights above 60. So what you can do is we'll go and draw and find out where 60 will fall somewhere within our scenario of one, or within our standard deviation. So let's have a look. If we've got the mean at 78.6. Now 60 is lower than that, so I need to go down. So if I go down one standard deviation, what's 78.6 minus 9.3 would be 69.3, yes? And then if I minus another standard deviation of 9.3, I get 60. So can you see what I'm doing there? This is minusing 9.3, minusing 9.3, yeah? So if we're at 60, we're at the 2 standard deviation. Now, it says how many people have a weight above that? So if we're at 2, this little pocket is 2.5, what would the rest of the graph be? You'd do 100 minus 2.5, which would be 97.5. Yes? Do you understand that? So, because it would all have to make up to 100. So really, we've got 97.5% of the 456 males. So you're going to do 0.975, change it to a decimal, times by 456. And what will that equal? So I got E, 445. Okay? So just be careful. The thing to look out for here is that it says number, not percentage. But this one's okay because it's a multi-choice, so there's no 97.5. You're not going to get accidentally write that. But in a short answer, that's what people accidentally do. They write the percentage, not the number. Okay, let's look at this last one. This one was very poorly done when it was done in the exam. So Brett and Sanjeeva or whatever, both play basketball in the basketball competition. So when the weights of the players in the competition are considered, Brett has a standardized weight of 0.96 and Sanjeeva has a standardized weight of negative 0.26. So which of the following statements is not true? So we're looking for not true. So what I suggest is we can use this one up. We can just think about our score. Just think about where those two are actually sitting in terms of this. So they're both negative. So if I go -1, but what is it? Brett is down here. He's closer to -1 and Sanjeeva is more closer to 0. So here's Sanjeeva. All right, so now this will help me with reading the comments. So we're looking for what is not true. So Brett and Sanjeeva are both below the mean in the basketball competition. That's true, isn't it? Yeah, that is true. Sanjeeva weighs more than Brett. Is that true? That's true, isn't it? This is your mean weight. You keep getting bigger if you go up there. Isn't Sanjeeva higher than, yeah? So that is true. If Sanjeeva increases his weight by 2 kilograms, he would be above the mean weight for players in the basketball competition. So what you could do here is you could work out what Sanjeeva's weight is from the Z score because we have all those things. So we want to know what Sanjeeva's actual weight is. We could do the mean, which was 78.6, plus his Z score, which is, what's Sanjeeva's Z score? Negative 0.26 times the mean, standard deviation, which is 9.3. So let's see what this is Sanjeeva's actual weight. Okay, so that gives me his weight of, I got 76.18. So is that above the mean? Now, if I add 2 kilos to it, so add 2, he would be 78.18. Is that bigger than the mean? Yeah, so if Sanjeeva increases his weight by 2, he would be above the weight. So this one is false. So this is our answer. You would probably stop there and move on. And then later on, if you want to check the other ones, we could check what Brett's actual weight is using that same formula as here. And the other one, more than 50% of the players in the basketball competition weigh more than Sanjeeva. That is true because we can see that one quickly. This is 50%, isn't it? And he's a bit below. So there's definitely more than 50% when you go from above Sanjeeva.